Have you ever wondered why the ground beneath us, which seems so solid and immovable, suddenly shakes and rumbles during an earthquake? Yes, it's quite a phenomenon to ponder. Earthquakes, as unsettling as they may be, are a natural part of our planet's geological process. They serve as a stark reminder of the dynamic and ever-changing nature of our world. Now let's delve a bit deeper. The Earth's crust is not one solid piece, but is made up of several large sections known as tectonic plates. These plates are constantly moving, albeit very slowly, across the semi-fluid layer of the Earth's mantle beneath them. Sometimes they slide against each other, move apart, or even converge. It's this movement that's the primary cause of earthquakes. Picture this: the immense energy that's built up as these plates move is suddenly released, causing the ground to shake. So, it's the movement of these tectonic plates that causes the Earth to tremble. But how does this process exactly work? The Earth's crust isn't a single solid shell, but it is broken up into giant pieces known as tectonic plates. These massive slabs of rock floating atop the semi-fluid mantle beneath are constantly in motion. They move at a pace that's almost imperceptible to us humans, only about the same speed that your fingernails grow. But over geological timescales, this movement has profound implications. The Earth's crust is roughly divided into 7 large and numerous smaller tectonic plates. Imagine these plates as puzzle pieces, fitting snugly together to form the surface of our planet. But unlike a completed puzzle, these pieces are always shifting, driven by the heat from the Earth's core. This heat creates convection currents in the mantle, pushing and pulling the plates above in different directions. These tectonic plates interact in 3 main ways, forming what we call plate boundaries. First, we have convergent boundaries, where 2 plates collide head-on. Here, one plate often gets forced beneath the other in a process known as subduction, creating deep-sea trenches and mountain ranges. Next, we have divergent boundaries, where plates move apart from each other. This gap allows magma from the mantle to rise and form new crust, creating mid-ocean ridges. Lastly, we have transform boundaries, where plates slide past each other horizontally. The San Andreas Fault in California is an excellent example of this. When these plates move, they don't do so smoothly. The edges can get stuck while the rest of the plate continues to move, causing stress to build up. When the stress finally overcomes the friction holding the plates together, energy is released in the form of seismic waves, which we experience as an earthquake. The energy released during an earthquake can be immense, equivalent to many atomic bombs. This energy radiates out in all directions, shaking the ground, toppling buildings, and in some cases, reshaping the landscape. So now that we know what causes an earthquake, what happens when one strikes? The effects of an earthquake can be devastating, varying from mild tremors that barely shake your coffee cup to violent shakes that can bring down entire cities. Immediately after an earthquake, we witness ground shaking and displacement. This is when the Earth's crust lurches into new positions. Imagine the ground beneath you moving like waves on the ocean, altering landscapes and redefining city skylines. But the immediate shaking is just the beginning. Secondary hazards soon follow. Fires often break out due to ruptured gas lines or toppled electrical lines. These fires, fueled by debris and difficult to control, can cause destruction equal to or even greater than the earthquake itself. Then there's the menace of tsunamis. When an earthquake occurs beneath the ocean floor, it can displace enormous volumes of water, setting off a chain reaction that results in towering waves racing towards coastlines, swallowing everything in their path. Landslides, too, are a common aftermath, particularly in hilly or mountainous regions. The shaking can destabilize slopes, causing a rapid downhill flow of rocks, mud, and debris that can bury homes and roads, cutting off entire communities. The loss of life and property in the wake of these events can be immense, and the impact on the environment and economy devastating. The scars etched by these natural disasters can take years, even decades, to heal. Earthquakes indeed leave a lasting impact, but understanding them can help us prepare better. So, to put it all together, earthquakes are a result of the movement of tectonic plates beneath the Earth's surface. The mechanism of these quakes involves the release of stored energy, which sends shockwaves across the globe. The aftermath can be devastating, causing extensive damage and loss. Yet, by comprehending the cause and effects of these natural phenomena, we can strive to be better prepared and lessen their impacts. Remember, knowledge is our best defense against the unpredictable power of nature.